after that, we have number 4, 5, 6, and 8. 5, 7, and 8. I know your guys' page seems to be misnumbered. That's what they told me in the last class. So I apologize for that. So these are questions that you're going to either tell me true, and you can draw a picture, or you're going to tell me it's false and explain why, okay? So the first one, can 2 points be non-collinear? Can you have 2 points that do not form a line? It's a 50% chance here, guys. So how many points does it determine to have a line? How many points do we need to have a line? 2, you're right. So 2 points determine a line. So any 2 points anywhere drawn, you can draw a line between them. So no, it is not possible. 2 points form a line. And then I just drew an example so you could see it. No matter where you put your dots on your page, you're always going to be able to draw a line through it. You could pick 2 dots somewhere else, and then maybe like this. You could always draw your line through it. That one's a little less pretty, but okay. Can 3 points be non-collinear? Is it possible to have 3 points that are non-collinear? Deshaun says yes, and he is correct. Ooh, didn't mean to take that away. Give me a second. So that is 100% true. You can, because how many points determine a plane? Do you guys remember this? Maybe? 3 points that are non-collinear. That's exactly right. So yes, because it's the definition of a plane. Okay, after that, there are points on A, B other than point A and point B. So if you got a segment and it tells you have a segment AB, are AB the only points on that segment? I heard somebody say it. What are those 2 points of the segment? Do you guys remember what we use? They're the what? When we label a segment, what are the 2 things that we use for our letters? They are the, you know this? Yeah, Josiah?
Beginning and the end.
Yeah, they're the endpoints. Yep. And so it's possible to have a line segment, AB. It's not only possible, it is, where AB are the points we define, but there's infinitely many points that occur in here. We just didn't label them. So we only labeled the endpoints when we're told it's a segment, but there could have been another point in there that we even had labeled, or plenty that we didn't. So yes, it's true. Okay. After that, we have, can collinear points be non-coplanar? Can collinear points be non-coplanar? So can you form a line with points that are not in the same plane? Okay, so with that, we see yes. We can. And then I'm going to draw you guys a picture of what would illustrate that. My picture might not be the best, but it is what I use to show it. So you have one plane right here. And then you have a second plane right here. So you can kind of see that would be the wall and the floor. I'm going to put 2 points on it. 1 point's right here. Another point's down here. And we can draw a line through it. So that line would go through it here. It'd be like my lanyard. It would form that hypotenuse of a triangle, essentially. And then our last one. Can coplanar points be non-collinear? Let's try that again. Can coplanar points, so points on the same plane, be non-collinear? So are we able to have those on the same plane? Or not on the same plane? Whew, let's try this again. Sorry, guys, you're in my 6th hour. Can coplanar points, so points on the same plane, not be collinear, not be on the same line? There we go. Is it possible to draw points in the same plane that aren't on the same line? Yeah, it is. I see you guys nodding. So here, we have coplanar points. We can draw a line through some of them, but not all of them are on the same line, right? So yes, it is possible. So how many points determine a line? Yep, 2. How many points determine a segment? 2. Because remember, it was those endpoints, so just 2. How many points determine a ray? Okay, I get a lot of the same answer, and I got some different ones. So I'm going to go here real quick, and when we name a line, right, we write AB, line over it. 2 arrows on the end. When you write a segment, you write AB, line over it, no arrows. How did we write array? Want to say it again? 1 point and an arrow. And what was underneath it? Could you give me an example of something underneath it? Okay. AB, point, arrow on the side. How many points determined that? 2. So how we write it? And then yesterday we didn't have an example like this, so I want to cover it with you now. How many points, we talked about this. How many points determine a plane? 3. And we talked about that part, but I never showed you how you'd write it. So if you have a plane right here, and I'm going to be very clever, and I'm just going to use A, B, and C, and I'm going to name it, that plane is named plane A, B, C. So any 3 non-collinear points, we just name it. So now starting on this, and this is our review. What is the pattern? Can anybody tell me what pattern's happening? Yep. We're adding 7, plus 7, plus 7, plus 7. So what is our next number going to be? 42. And the next one? 49. So can anybody describe what this pattern is? Yep, we're dividing by 2. 200 divided by 2 is 100. 100 divided by 2 is 50. 50 divided by 2 is 25. 25 divided by 2? 12.5. I'm also okay if you want to write 25 over 2. If you want to prefer the fraction, I'm good with that as well. In the section that says, determine if each conjecture is true. If false, give a counterexample. What does the word quotient mean? I heard somebody say it, division, yes. So if you remember, quotient means division. Put a little division symbol above it. So the quotient of 2 negative numbers is always a positive number. So we believe it's true. So to show it, we're going to do at least 3 examples, okay? So your first one up, give me a negative number. Okay, negative 7. What can I divide negative 7 by? What? We can do it by negative 1. And what do we get? We get positive 7. Yep. Next example. Okay, I heard somebody else yell out 3 earlier. What's something that's divisible by 3?
9.
So let's do negative 9. Negative 9 divided by negative 3. What do we get?
Positive.
A positive 3. And example, our last one we had to do. And what is it? 25. So negative 25. What are we dividing by? Negative 5. And what do you get? 5. So we see that, yes, the conjecture is true. Yes, conjecture is true.
Pick that up.
No, it's okay. I just thought it was something else. Okay, after that, we have a prime number. So what do you guys remember what prime numbers are?
They're only divisible by themselves.
They're only divisible by themselves in 1. That's 100% correct. Okay, so we don't consider 1 to be a prime number, standardly. What is our first prime number?
2.
Yep, because 2 is 2 times 1. What comes after that?
3.
3. Is 4 a prime number? Nope, right? Because you can do 2 times 2. How about 5? Yep. 6? Nope, because you can do 3 times 2. 7? Okay, so we have more, so we're just going to leave it like that. So, on this, do you see that, in fact, all of them are odd? No, which one's not odd?
2.
No, 2 is even. And that is your answer. Your counterexample was 2. You told me no, and you told me which one was your counterexample. Okay, the last one. The square of an odd integer is odd. So we have 1 squared. is 1. What's 3 squared? 9. 5 squared? 25. Let's do 9 squared. We'll skip 7. Okay, let's just see if you guys might remember this. 11 squared? 121. Okay, that's nice that you actually remember that. What do we see here? Odd squared numbers are odd. So yes, conjecture is true. Okay. How many points determine a line? We just did this. 2. How many determine a ray? 2. How many determine a plane? How many determine a point? 1. Okay. And then we have one last question that I'm going to make you do. Number 16 on there was just saying those are things you need to be able to do. So you need to be able to draw lines or identify lines. You need to be able to identify planes. You need to be able to identify segments, all of that. So if I was studying for that, I would take my notes and I would cover up our answers and I would look at those same graphs. I did the same thing with the homework. I would look at those again to make sure I identified them correctly. So this one I'd like you once again to try. So this is the question. Draw 4 points, V, X, Y, and Z. No 3 of those points can be collinear, so they cannot be on the same line. Sketch the lines VY, XZ, and YZ. So take a second. So the first thing when we do is we want to start sketching line VY. These should all have the arrows and the line above it. My computer just wouldn't let me do it. So we want to sketch that one first. So first one here. Ooh, that's rough. Let's try it again. One line. And we now have VY. We know that X and Z cannot be on that line. So we've drawn this one so far. I'll box it in so I know which one I'm done with. Which one of the 2 that are remaining has one of those 2, a V or a Y in it? Which one? The last one? So the last one does, right? We have the Y, and that one's YZ. So our next line has to go through that point. So we draw it like this, or any way you'd like, as long as that point's not on the same line. This was just my example. So again, as long as it's not on the same line and it goes through that first point, you can draw it any way you'd like. Goes to the first point, not on this same line. And then the last one, the one we haven't done, is that XZ. Well, we see Z's now on the second line we drew. We don't want X to be on that first line we drew or the second line we drew. We can draw that either direction now.
Do they have to be like connected?
Say it again, hon.
Do they have to be connected like that?
They have to be connected.
I just drew 3 lines.
So yours is the most common one in the room. I'd say 80% of the people did that. So 80% of the people in here drew something that looked like this. X, Y, Y, V, and then another one. You can't do it that way because you named 2 points in the same plane, the same thing. And so essentially they'd still be the same points. You just have to rejoin them.